All right, lesson 1.5, rewriting equations and formulas. You guys notice how chapter 1 in 8th grade math and chapter 1 in algebra are kind of going along with the same content? Math repeats itself. It builds on itself. So as you learn concepts, the next year you take the next math class, it reviews what you should already know, and then it adds more to it. So it's really important you understand the foundational stuff. So let's go over this vocabulary algebra. Somebody tell me what a literal equation is. Nico.
An equation that has two or more variables.
Two or more variables. And what is a formula, Chloe?
A literal equation that shows how one variable is related to one or more other variables.
Right. So that's, long story short, they solve for one variable, like y equals and then everything else. So that's what a formula looks like. All right. So let's go to example 1. So we're going to solve this literal equation. Why is it called a literal equation?
Because it has more than
two
or more variables.
Correct. It has two or more variables. Very good. It has an x and a y, so that's why it's a literal equation. So what are we solving for?
Solve for y.
Yeah, solve for y. So rewrite the equation, and we're going to get y by itself. Now we can't move the 3 because it's touching the y, so let's move the other stuff first. How would I move the 4x? How would I do that?
By
Subtraction, because this is addition. Very good. So subtract 4x from both sides. And you can't combine the 9 and the 4, so you would just write 9 minus 4x. Why can't we combine the 9 and the 4?
Because one's a variable, one's not.
One has a variable, one does not. Yes, the 4 has an x with it, the 9 does not. All right, so now the term with the y is isolated, so we need to get the y by itself. How do I get rid of the 3? Divide by 3. Now remember, you're dividing everything by 3, so the 3 by 3 gets rid of it, and then on the right-hand side, remember the butterfly? We're going to divide both terms by 3. 9 divided by 3 would be what? 3. That one's simple. Can 4 be divided by 3? Very pretty. No, just leave it 4 over 3. Yep. Now have we isolated y?
Yes.
Yeah.
So are we done?
Yeah.
Yep.
Oh yeah.
We solve for y. So your answer is 3 minus 4/3 x. Y equals 3 minus 4/3 x. Yeah, so much like what 8th grade was doing yesterday, you guys are just rearranging the equation to get a variable by itself. And it will specify which variable. All right, so go do monitoring progress. Nope, just kidding. Example 2. I knew that was too easy. All right, solve the little equation for which variable now? X, so a little bit different. So start off by writing your variable. You'll notice you have an extra letter in here that we're not used to, correct? There's a Z. Oh no. It'll be okay. So first thing we need to do, what would you guess is the first thing?
Isolate x.
Well, I mean, that's the goal, is to isolate X.
So we do 3x.
Oops, I didn't mean to click.
Plus 5x.
So here's the catch. There is an X with both terms, correct?
Yes.
However, we can't just divide the X out of here very easily because it's got that plus sign in between it. So this is where you're going to hear, you're going to undistribute. This is kind of factoring. So the X means it's multiplying by those things, right? So if I were to pull that out into parentheses, that would still be multiplying, correct? So think about distribution. Look up here. If I undistribute, I'm pulling the X out of each term and putting it on the outside of the parentheses. If I were to distribute that back in, you would go back up to that top equation, correct? So that you're going to pull each letter out of each term so that we just have it on the outside. Because once it's here, what can we do? It is multiplying. We can
divide 3.
we can divide. Well, we want to keep the 3 plus 5 over there because we're solving for. Oh no, we divide by. You're right. We want to solve for the x. So yeah, we can divide by everything else. So divide by the 3 plus 5z to move it away from the z. So then it just cancels on the right. Can we simplify the left side with the y and all that? Nope, because you can't combine any of that, so you're just done. And then the proper way is to flip it and write the x first. So y over 3 plus 5z. Yep, would be your solution. So this undistributing takes thinking outside the box a little bit. So when you see a term with the variable you're trying to solve in both of the terms there, think to myself, how can I pull this out of there? And that'll hopefully help you remember. Any questions? All right. Now we're going to do monitoring progress. Yep, 1 through 6. Ooh. All right, so work on 6 questions, and then we'll do our example after that. Oh, I need to make this bigger. All right, example 3. Okay, hold on, my face is not here. Hello, face.
Missy, I think I got an equals MC squared.
Excellent. Einstein. All right, the formula for the surface area of a rectangular prism is this formula. S equals 2LW plus 2LH plus 2WH. We are solving for L. This looks intimidating. It is fine. Just take it one step at a time, okay? So first step, write the formula. You can do it. We're solving for L. Are there any one of these terms that don't have an L with it? The last one. So the last one we can just move across. How do we move it across? Subtraction. Very good. So we're not going to be able to combine much of this stuff, so you just rewrite it all messy. S minus 2WH equals 2LW plus 2LH. Correct. All right, so now, ready? Good? I'm actually talking to y'all. Oh, no wonder. I was like, why is Nico talking? No, this is y'all's. Hey, we're doing example 3.
I was watching the video, but I didn't hear something.
That's hilarious. It's tricky when I'm teaching y'all similar things.
Okay, I'm listening.
He's on it. All right. So now I have the L, but it's in 2 terms here. So how can I pull out the L? Put parentheses, which is undistribute. So I'm going to pull the L out by undistributing the L. That's a cursive L. So it doesn't look like a 1. Now that I have the L outside the parentheses, which means multiplication, how do I move away all the other content? We divide. So divide 2W plus 2H from both sides. So that gets L by itself. L equals S minus 2WH over 2W plus 2H. Yep, we're just rearranging the alphabet. No big deal. Any questions on how we did that? No? Other than, hey, it's your example?
Yes, wait.
Another one? You have to wait till I'm done lecturing. It's all good.
Okay, got it.
Excellent.
That does make sense.
Good. All right, so let's look at example 4. Come on. All right, you own a rectangular lot that is 500 feet deep. It has an area of 100,000 square feet. To pay for a new water system, you are assessed $5.50 per foot of lot frontage. So A, we're going to find the frontage of our lot, and B, how much are we assessed for the new water system. All right, so if you look at the picture, what is the frontage? Because that's a weird word. Yes?
The side. The width.
I mean, it's the width. You are correct. It's the part that's against the road. So this is an actual term they use in the real world. The frontage road. You hear frontage road? It's the part of the property that meets the frontage road. All right. So we're trying to find the width here because you see the frontage is the same as the width. So what is the formula for the area of a rectangle? A equals length times width. Very good. So we need to plug in what we know to solve what we don't know. Do we know the area?
Yeah.
So plug that in where the A is. And we know the length? 500. Plug that in. Oh, they solved the equation first to where it's by itself. You don't have to. You can just plug things in. It'll work either way.
That looks like a T for T.
It's an L. Yep. All right, so you're going to rearrange the equation and solve for W. You get, what's 100,000 divided by 500? 200. So the width equals 200. So how long is the frontage road, or frontage? 200 feet. Now it says they're going to, so that's A. That's the frontage. So then B, how much are you assessed? So if it's 200 feet long, what are we going to do to find out the total cost?
2 times 5, 450.
200.
200.
Correct. 200 times $5.50 will give you, correct. We'll give you $1,100. So it's going to cost you $1,100 to have that frontage road. Or to have that piece of property against the frontage road, I guess is what it is. That would be the same as 1,100. That is correct. It's just two different ways you can say it. 1,100 or 1,100 is the same thing. All right, monitoring progress 7 and 8. Probably gonna move on pretty quickly because we have 2 more examples. Ooh, we have 3 more examples. Ooh, Lord. All right, we're gonna keep going. So yeah, go straight to the common formulas. Write that in your journal. You'll have to finish the monitoring progress on your own time. We have a lot of examples to get through. Just write these 3 formulas. You don't have to write like everything. Just put temperature and then the formula, and then interest and then the formula, and distance and then the formula. That's plenty.
Wait, see, Celsius?
Yep.
Miss Dees, how many examples did 8th grade have yesterday?
They had more than normal too. I think they had 5 or 6.
We had 5.
Yeah, I think it was 5. It's just a longer lesson. Oh, that's help?
Yeah.
Do y'all need more time to write? Because I need to go on to the next.
No, I'm good.
I'm done.
Yeah, I got to keep teaching. Evo, you'll have to wait. Skip it and go to the next one. And come back to it. All right, we're going to solve the temperature formula for F. So what is the temperature formula? You just wrote it down?
C equals 5, 9,
C equals 5.
parentheses, 3, 2.
F minus.
Perfect. All right. Boy, if y'all were watching me teach 8th grade yesterday, you would have seen this. So the first thing we need to do when solving for F, we can't move the 32 first because it's inside of parentheses. So we have to deal with what's on the outside first. So how would I move that 5/9? Divided, but when you divide a fraction, you actually
Multiply.
flip it and multiply. Don't forget the word flip it. You can't just multiply. You got to flip
So
it.
you do times.
So you do 9 over 5 times C. And it cancels out the 5/9. So now I've been able to drop the parentheses. So can I move the 32?
Yeah.
How do I do that?
Plus 32.
Plus 32. So 9/5C plus 32 should equal F.
Should equal F. Oh, okay.
9/5C plus 32.
So, and we would just have to plug in C and F.
So usually they'll give you one of the temperatures. So they'll probably, like if we're solving for F, then they probably know what Celsius is. So they'll say, put Celsius is 22 degrees. Plug it in and find out what Fahrenheit is. Very good.
I think the other number can tell us how to solve the interest. And the...
Yep. We're just going to do them real quick. Okay, so on this, I'm going to let you guys watch the video on this one because it's literally plugging in one of the temperatures. So they know the temperature for Mercury and they want to know what it is in Fahrenheit. See how the two planets have different Celsius and Fahrenheits? So you're comparing which one's hotter. Okay, so y'all can go watch that later. Let's do example 7. All right, so we're going to use our simple interest formula. You deposit $5,000 into an account that earns simple interest. After 6 months, the account earns $160.50 in interest. What is the annual interest rate? So annual interest rate in your formula is which letter? R. So we're going to solve for R. So how would we get R by itself here?
We have to divide by P and then divide by P.
Yep, at the same time. You can take them both. So now that we've solved for R, which is what we're looking for, we can plug in all the numbers that we do know. So what is the interest that we earned?
Interest rate, 162.5.
162.5. What's the principal?
The principal.
That's the amount we deposited, 5,000. And then the time on this formula is always in years. So if they give you months, you have to put it as a fraction or a decimal. Since it's 6 months, is that half a year?
Yes.
6 over 12, right? Because there's 12 months in a year, so that's why you see the 0.5. Okay, so the time, when you use this formula, it's always in years. So if they give you your data in months, just say the number of months over how many months are in a year is 12. So that's why you see they put 0.5 here. It's real easy to mess that up. Whenever you get to this and you start doing it in your homework, if it comes out wrong, check your time first, because I bet it's in months and you put it in and it's supposed to be in years. All right, so now you just do this on your calculator. 162.5 divided by
0.065.
all that mess. 0.065. That is the rate. Now, most rates are given to us in percentages. How would I turn this into a percent?
You would do 0.065 times 0.5.
No, you just move the decimal. So if I think 100%, how many zeros are in 100? There's 2, so we're going to move the decimal twice. So we're going to go to the right. 1, 2, between the 6. 6.5% would be the... Now, if you answer 0.065 as the rate, that is correct, but the more appropriate answer is 6.5%.
So do we enter 0.065 on the big ideas or 6.5?
It depends. If it has the percent sign on you know how it has the box and then a sign after it, then it needs to be the 6.5. Okay. So just check and see what it's looking for. Excellent question. All right, everybody got that? I know I'm kind of pushing us through it, but we were running out of time. All right, so example 8, shockingly, is the distance formula, since we wrote that down. So you already know you're using the distance formula. A truck driver averages 60 miles per hour while delivering freight to a customer. On the return trip, the driver averages 50 miles per hour due to construction. The total driving time is 6.6 hours. How long does each trip take? So grab your distance formula, and we're going to rewrite it so that the that it represents the 2 trip times. So we need to solve for t. So d equals rt, and let's solve for t. If you rearranged that, it's right here in the middle of this paragraph. What would you get? T equals what?
T equals D divided by R.
D divided by r. So now we've rearranged it for time. We don't know the distance, right?
Yes.
So you can represent each one by d over 60, because the freight driver, oh, we do know how far, 60 miles. Oh, that's per hour, that's why. He's going, that's how fast he's going. And then the return driver did 50 miles per hour. So the distance divided by the miles per hour. And then how long was the total driving time?
6.6 hours.
6.6 hours. That's why you see that here.
So,
So now we need to simplify. What is d over 60? Can you add those together?
yeah.
Yeah.
Nope. I know you think you can because they look like they're like terms, but now you got to look at that like a fraction.
Also, denominators.
So the denominators you could not directly add. You would need to find the common denominator, which would be 300. Because you're going to have to multiply what times 60 equals 300?
1150.
No, it's 11. Right? No, it's not 11.
No.
It's 5.
50. 5. It'd be 5.
It's 5.
5.
Oh, I said 11.
Because they added the 2 on top. So they skipped a step here. Let me show you. So they got a common denominator. So if I have d over 60 plus d over 50, the common denominator is to multiply this times 5 and multiply this times 6.
Yeah.
It's the easiest way to do it.
Yeah, that's it.
So 60 times 5 would be 300, but you have 5d. 6 times 5, 50, I'm sorry, would be 300. 6 times d would be 60. Now we can add across. 6 plus 5 is 11d over 300. And that equals 6.6, right?
11.
Yeah, 11d over 300. Now we can solve for d. How do you move the 300?
Times.
Times. So times 300. So what's 6.6 times 300?
11D is 900. What? 1,900. So 6.6.
Okay, and then the last step.
You simplify
How do I move that?
by dividing by 11.
So then d equals,
180.
and d stood for distance. So this is it, what label?
D equals.
Miles.
Oh, miles.
So that's one direction, of course. Did it ask us for just the one way? Total driving time. How long does each trip? Yeah. So each trip was 180 miles.
So for the 5Ds plus 60, just take out the 0. Because 1560 plus.
Oh, so you get the common denominator? Yeah. Yeah. So a rule of thumb is if you're trying to find the common denominator between two things, if you can't immediately think of it, you can multiply one times the other. But if they end in the 0, then you just multiply by the first one. So you're going to multiply the 5 times the 60, but you don't have to do the 0, and you'll do the 6 times 50.
Oh.
Yeah. All right. That is all of the examples. So you just need to finish through number 11 for your homework.